Okay, hi everyone, we're going to be carrying on with straight line equations today. Last lesson with new content, and then next lesson we're going to be doing a recap lesson on the stuff we've done, and then we'll be moving on the following lesson after that. So, a quick starter, so I'd like to pause the video now. This is stuff we did in yesterday's lesson. So today's lesson will build on that, so if you're a bit shaky on that, I'd go back and have a quick look. So 2 questions, pause the video now, have a go at it, and I'll put the answers up, and then we'll move on. So pause the video now and have a go at that. Okay, assuming you've paused and had a go, I'll reveal the answers now. So I've got our 2 answers there. So you can pause the video, check your answers for them. So with the first one, we've got the gradient, we've got a point, so you substitute in the gradient. And then after that, you then have to work out what the constant is, the c at the end. Second one, same idea, it's not showing the full working, but you need to substitute in the gradient and then rearrange it to work out what c is. Okay, so what we're looking at today is parallel lines. So I'm sure you will have had plenty of lessons on parallel lines before. We're focusing just on the straight line equations today though, so we're just looking at what it means if 2 lines are parallel. So we've got 2 lines here on our graph. We've got the line with C on it and the line with A and B on it. So what is the same about 2 lines if they're parallel? So looking at these 2 lines, what do they both have in common? So particularly looking at the slope of the line, we can see that for them to be parallel, the gradient has to be the same. Because if the gradient isn't the same, there'll be a different slope and they'll cross at some point, so they won't be parallel. So what we need to do is, with these, we know if we can work out the gradient of one, that'll tell us the gradient of the other, because we know they're parallel. So what we're going to have to do is use the line with the AB on it to work out the gradient, because we've got our 2 points on there, and then we use that information to work out the line equation for C, for the one with C on it, so that's line L. So the first thing we're going to do, we're going to use this line, the one that's got A and B on it. So let's work out the gradient. So the gradient, or M. So to work out the gradient, we do the change in y divided by the change in x. So y is going from 5 to -1. So do change in y divided by change in x. So that gives us, so it's -6 is the change in y. Then x has gone from -1 to 2. So that's changed by 3. So that tells us our overall gradient is -2. And we get told in the question that L is parallel to AB. So because it's parallel to AB, we know that the gradient of this line is the same. So we know that this line is y equals, and it's going to be -2x plus some constant. I'll call it C, a little bit confusing because of that, but we'll just treat it, it's not the same C as this, it's just a constant. I'll call it C1, so we know it's a different one. Okay, so now what we need to do is use our coordinates here for this point on the line to work out what C1 is. So let's substitute in those coordinates. So we've got the y value is 5, so wherever there's a y we're going to put a 5, so we have 5 equals, so we've got -2 times, and the x coordinate is 0, so -2 times 0 plus c. So I'll just move this over here so it's got a bit more space. So at the moment we've got 5 equals -2 times 0 plus c. So anything times 0 is just 0, so this is going to vanish. So we just have 5 equals c. So I've worked out what our constant is. So that tells us, going back to our line equation up here, so y equals -2x, and then we've got our c plus 5. So that is our equation of the line. So the key steps where we work out the gradient of this line, and then from then, it's just like what we were doing last lesson, where we have a gradient, we have a point on the line, we can work out the line equation. Okay, so we're going to do another question. It's very similar, but this one has a little shortcut that we can use. So we can see we've got 2 lines. One of the lines has got 2 points given to us, and one of them just has 1. So the one that has 2 points, that's the one we can work out the gradient of, because you need 2 points to work out the change in y and change in x. So we're going to start out by working out the gradient. And we know that the gradient of this one will be the same as this one because they are parallel. So m equals, so it's change in y. If you want to have a go at this one without me going through it as well, feel free to pause the video and have a go. You don't have to watch this one because it is quite similar to the other one, but I would recommend when you've got your answer, come back and have a watch because there is a bit of a shortcut. So change in y over change in x. So let's go. So we've got minus 2 going to 3. So our change in y is 5. Our x value goes from minus 6 to 4. So that is a change of 10. So that means our gradient is a half. Okay, so we've got our gradient of this line, which is also the gradient of this line because they're parallel. So we know that our second line, the line L, is going to be y equals a half x plus some constant that we don't know. So we could do what we did in the previous question now and substituting the coordinates. We're going to take a very slightly quicker route though. It's only slightly quicker, but we can see the point we're given is this point. And if you're quite sharp, you'll notice that this point is on the y-axis already. And we know that this is the y-intercept. So if you're very on the ball, you can notice, right, I don't need to do the substitution. I already know the y-intercept is 4. So straight away you can go from here to y equals a half x plus 4. If you wanted to just stick with the method that we've done already, completely fine to do that, you will get the same answer. Let's just check. So y equals a half x plus c. Let's substitute in 0 for x and 4 for y. So we've got 4 equals, we've got a half times 0 plus c. This is going to vanish because anything times 0 is 0. So we've got 4 equals c. So then lastly, going back to our equation here, we've got y equals a half x plus 4. So you can see a little bit less working with this method, but this method works with any coordinate. So if you have to remember one, I'd go for this one because it works in all cases, but if you're feeling pretty crafty, there's a nice little shortcut you can use there when it's on the y-axis already. Okay, so now some practice. So this is similar to what we were doing last lesson, because you're given a point on the line, and you need to work out the equation of the line that goes through that point. Sorry, it hasn't got the question here. Work out the equation of the line. Work out the equation of the line. So the key thing to look at is that it is parallel to, and then it tells you another line. So if it's parallel, that means it has the same gradient. So for this first one, it's going to be y equals 3x plus something. You need to use this coordinate then to work out the something. So if x is 0 and y is 2, we've got 2 equals 3 times 0 plus c. So as a c equals 2. So answer for this first one, y equals 3x plus 2. So we've worked out our constant at the end by substituting in. So pause the video now, have a go at these ones. If you're feeling confident when you've done the first couple, feel free to skip ahead and have a go at some of the harder ones right at the bottom. If you're feeling like you benefit from working through all of them, do that. There will be another question, there is more questions as well, so don't spend ages on these ones. I do want you to have a go at some of the other ones as well, so if you are feeling confident with them, feel free to move on. Here's the answers to those previous ones, so well done if you managed to get them. You can see they do get a little bit harder, you get negatives and fractional gradients, but the method is still the same. Okay, so in the second section of the task, there's quite a hard question on question 2. So I thought I'd do an example of that sort of question as well. This is actually very similar to the questions we did at the start, it's just you're not given a graph. So I'm going to show you how you would do it just without a graph, but if you were in doubt, feel free to draw a graph and that will very likely help. So, give the equation of a line which passes through 0, 1 and is parallel to another line which passes through the points 1, 3 and 8 to 24. So we notice with the second line, we're given 2 coordinates, so that is one we can work out the gradient for. So we can work out the gradient. So we do that by doing the change in y over change in x. So let's work that out. So the change in y goes from 3 to 24, so that changed by 21. The x value goes from 1 to 8, so that changed by 7. So 21 divided by 7 gives us a gradient of 3. So that tells us, because these two lines are parallel, tells us in the question, that our other line, the one that goes through this point, is also going to have a gradient of 3. But we don't know what his y-intercept is, so it's going to be y equals 3x plus whatever the y-intercept is, we don't know. So thinking back to the nifty shortcut that we saw earlier, we've got, if we look at this point, what do we notice about this coordinate? So if you're pretty eagle-eyed, you'll notice that it is on the y-axis because it's got an x-coordinate of 0. So if shortcut method, we would just go straight from that to y equals 3x minus 1, because we've got our y value of the y-intercept. If you wanted to go for the slower but more reliable method, we've got y equals 3x plus c. So what we need to do is substitute in those coordinates. So the y value is minus 1. The x value, so we've got 3 times, and our x value is 0, so plus c. So that'll be minus 1 equals c. So again, back to our equation here with our new value for c, we've got y equals 3x minus 1. So you see you get the same answer either way, it's just this one, it's a bit more writing, but it is a bit more reliable. So this is very like the questions too. So in the next slide, the questions there are some hard ones, it's a bit harder than that first task. So if you do run out of time, don't worry too much because they are tough questions. However, if you do get on some of the hard ones, very well done, because they are a bit above where we need to be at the moment. So here's the exercises, it is on the sheet as well, and the answers are included, so do check as you're going along. Particularly, so this one, that's pretty much what we were doing last lesson, so if you wanted to do a bit of a warm-up on that and then go on to this, that's fine. Or if you're confident with what you're doing last lesson, you can ignore question 4. So 1, 2 and 3 are the main ones. If you do finish them, there is this extension question, but it is quite a tough one. So feel free to have a go, but bear in mind it is quite tricky. And one last extension, if you do finish them, you can feel free to have a go at this one, just an extra one, so it's tying a few different skills together that we've used before. So I'll put the answer to this on the next slide. Okay, very well done if you managed to make it to here. So the answer's up here. So basically you need to work out the equation of the line, and then from that you're looking for where it crosses the x-axis. So to work out where a line crosses the x-axis, that is where y equals 0, so that is where this is from. So if you imagine you've got your line, oh, it's not bringing it out, it's slightly neater. So you've got your axes, you've got your x-axis, your y-axis. So you've got your line coming along here. So where it hits the x-axis, which is what the question is looking for, you can see that the y value has to be 0. So to work out where it hits the x-axis, we set y equal to 0, so that's why they've done this step here. And then they've worked out the coordinate for the x-intercept.